In this video, I'm going to talk about the Chapter 2 Instruction Execution Cycle. Each machine instruction must be executed by CPU. CPU will go through a predefined sequence of steps to execute the machine instruction. The sequence of steps is called the instruction execution cycle. Here we have about 5 steps. To execute the machine instruction, the CPU must fetch the instruction first from the memory. We know memory is outside the processor. So like we did in previous lecture, let me go up. Here in this you can see memory chip is outside the CPU, and whenever you need the data or code in the memory area, you need the computer is going to use data bus or address bus to do the reading or writing. So fetch instruction from here, the memory chip. Okay. Right after computer execute the first fetch instruction step, is going to increase the instruction pointer. This is a register. This register is holding the next instruction who's waiting online for to be executed. So step 1 is fetch. Step 2, CPU is going to decode the instruction by looking at the binary code. Each binary code of instruction has a binary pattern. This bit pattern will reveal what kind of operation it is. For example, if you have a statement like z equals x plus y, if this is in machine code, and based on the binary pattern for this statement, and the computer is going to find out the operations will be about the addition. So decode is to find out what kind of operation it is, and this one is for adding two numbers. To decode a machine instruction, the CPU also need to know what kind of operands it may need. Like for this adding operation, you need two operands, variable x and a variable y. Both x and y are variables that are values inside the memory chips. So to do the addition of x, y, you need the CPU need to get x value, y value from the memory chips. Both x and y are called operands. They are input values, and the decode instruction will find out is adding and also is going to prepare for reading x and y from memory chips. So in step 3, CPU need to fetch the operand from the register and memory. Some most use the data or instructions that hold inside the registers. There has to be the storage units inside CPU. So not necessary every time CPU will need to read from memory chips. Sometimes the data or code could be inside the registers. So that's why fetch operands could be from registers or could be from memory chips. If it's going to be outside the reading, that means the CPU need to read from here, and the CPU need to send the address on the address bus. So the memory controller is going to respond by putting the right data to the data bus, then bring back to the CPU to give LU to execute. So that's step 3, fetch operands value from register or memory. Step 4, CPU is going to execute the instruction. Execution is taking place inside the arithmetic logic unit. So for the execution, it's going to use the operand values, then do the operation. Finally, if you have output, the output operand will be saved or stored to a location. For this example, z equals x plus y, and we have to save the value z and bring the z value. If z is a variable, so z could be here. So the variable is memory chips. So step 5 is going to be store their values. We usually simplify this complicated sequence into just 3 basic steps: fetch, decode, and execute. Here we have a block diagram. This diagram helps to show relationships between the components that are interacting with each other during their execution cycle. First, to execute instruction, the code will be fetched from memory and bring back to the CPU and store it inside a code cache. After that, the instruction pointer is going to increase the value by 1, because the instruction pointer is going to hold the next instruction's address in the memory. So your CPU will always know where's the next instruction who's waiting to be executed. So IP is important. It remembers where's the next instruction to be executed. The code after is inside CPU is going to be analysis by the instruction decoder. This instruction decoder is going to find out what kind of instruction it is, then send a signal to control unit. Then control unit is going to tell the ALU to do their execution, or tell the floating point unit to do the executions. Some also use code or data that are saved inside a code cache and a data cache. Registers are high-speed storage that are used to hold values when ALU is doing processing. There are many registers inside the CPU. Thank you for watching this video.